Hi gents, we're going to have a quick little look here at the last little bit that we'll do of the circle, coordinate geometry of the circle. And it's how to get the equation of a tangent to a circle at a given point. Okay, so let's take two examples here and we'll give you one to try out. So we'll say that there's an equation which is x, sorry, I might make this a wee bit bigger. That's perfect. Okay, x minus 4 squared plus y plus 3 squared is equal to 10. And this is some circle, beautifully drawn. And what it's saying is, what is the tangent at a point which we're told, which is on the line, and this is 7 minus 4. Okay, what is that? What is the equation of that line there? Okay, so in order to get the equation of a line, you're going to need two things. So first of all, let's try and draw that out a little bit better, and we'll draw it out to the side. Wow, that's really awful. Let's just say that's what it is. So first things first, let's say that we know, what was the point? I've already forgotten it. Sorry, 7 minus 4. Okay, let's say that it's there. Okay, 7 minus 4 even. Again, the question is, what is the equation of this line here? What's the equation of the tangent? Tangent, a line that hits the circle in only one place. Try and come up with the plan. Maybe pause me and come up with the plan first. Remember what you need for the equation of a line. You need a point on the line. Done. And you need a slope. So just try and figure out how are we going to get the slope of that. Okay, well you haven't seen it before, so don't worry if you didn't get it. This is how you do it. You get the center of the circle. Remember, if it's x minus h squared plus y minus k squared is equal to r squared. Okay, let's say that we know that thing there. What we can say here is that minus h equals minus 4. And we can say that minus k equals 3. So the center, which is meant to be h and k, h is 4 and k is minus 3. So this is 4 minus 3. And what we need to do is we need to get the slope of the tangent, but we know that the tangent is at right angles. So if we get the slope between 7, I'll do it actually over here. You can get the slope between 7 minus 4 and 4 minus 3, you're good to go. So slope is equal to y2 minus y1 over x2 minus x1. There's a few ways of doing it. x1, y1, x2, y2. So y2 minus 3 plus 4, watch out for the signs, over x2, which is 4 minus x1. Okay, this is equal to 1 over minus 3. So your slope is minus a third. Now that's the slope of the line there, which is at right angles. So if you have one slope is equal to, let's just call it p over q, the perpendicular line, the line that is perpendicular to that, is minus q over p. So you turn it upside down and you change the overall sign. So if we have, and we do, that this has a slope of minus 1/3, then this one has a slope of 3 over 1, or just 3. Well, there we have it. We've got a point and a slope. We just have to use our formula in the tables book. Y minus y1 equals m times x minus x1. Do not use the point 4 minus 3. It is not a point which is on the tangent. You must use one that's on the tangent. So it's going to be x1, y1, so y plus 4 is equal to 3 times x minus 7. So no fractions to even worry about. If you do, write it as 3 over 1, or whatever the appropriate fraction is, and x minus 7 over 1, top by top, bottom by bottom, and go from there. 3x minus 21, okay, 0 is equal to 3x minus y minus 25. Okay, and that's the answer. I'm taking this from, just in case you wanted to know, 8.8. So we'll just have a quick little look. 8.8, question 5. and it says 3x minus y minus 25 equals 0, so we are good to go. Let's try another one. We shall try x squared plus y squared minus 4x minus 6y. Notice how this one is in a slightly different form to the one we had. So this is some circle, and the tangent, sure, we'll draw it here. It doesn't have to be accurate, and it isn't. So let's say that's the tangent, and it says that it has a tangent at 5, 7. Okay. So it's the same plan. Okay, same plan all over again that we had. God. It's bad enough when this is just in class, but now to be broadcasting this to the world is awful. Okay, what we need to do is we need to get the center there. Remember, it goes x squared plus y squared plus 2gx plus 2fy plus c equals 0. So in this case, 2g is minus 4, 2f is minus 6, and remember the center is minus g minus f. Okay, so g is minus 2, f is minus 3, and the thing that we want, minus g, is positive 2, minus f is positive 3. So we now have our center minus g minus f, 2, 3. There you go, 2, 3. We need to again get the slope of this portion here. Yeah, it's really not right, but anyway, 2, 3 going to 5, 7. Here's one way to get the slope. It's the rise over the run. The rise is how much you've gone up in y value. Rise over run. Okay, that's what slope is. Rise, the y value. Going from left to right there, we've gone up by 2. And how much will we move over by? Well, that's our x value. We've gone from 2 to 5. That is 3. So that is the slope of that thing there. It's 2/3, which means the slope of the perpendicular line. The slope of this one is 3 over 2, but change the overall sign, minus 3 over 2. Okay, we've got 5, 7. It's a point. We've got the slope minus 3 over 2. Here goes. Y minus y1 equals m times x minus x1. So it's going to be x1, y1. Y minus 7 is equal to minus 3 over 2. I would write it like that. Over x minus 5. Sorry, times x minus 5. And I put that over 1. Top by top is minus 3x plus 15, bottom by bottom, 2, multiply both sides by 2, 2y minus 14 equals minus 3x plus 15. Bring it all over to one side, 3x plus 2y. You can bring this one over as well if you want, minus 29 equals 0. Don't leave out the equal sign, it's real important. So which one was that? That was exercise 8.8, and I think I took question 9. I did. So exercise 8.8. Question 9, we'll just double check it here. 3x plus 4y. Okay, we've got something very different. Did I go through that too fast? Maybe I did. Was it question 9 that we actually did? It was. I'll just do a quick little double check here because I really don't have to do this video out again. So x squared minus 4x. Okay, so the center we said was 2, 3. The center is 2, 3. The point is meant to be 5, 7. Okay, rise, which is 4. Oh my god. Did I really say that? Did I really say that? Why did I say 2? What was I thinking of? Who knows? 4/3. God, that's awful. Okay, 4/3. Well, that's it's a fast fix, thankfully. 4/3, which means that, what's this going to be? This is going to be minus 3 over 4. Okay, minus 3 over 4. So a lot of that actually stays the same. Minus 3 over 4. Okay, so the bottom bit, yeah, simply the bottom bit just becomes 4. Nothing much to that. Top by top, bottom by bottom, it's still good. So what do we end up getting now? Slightly different. 4y minus 28. whereas this is still minus 3x plus 15. Okay, so let's totally wipe that out. What do we get? We get 3x plus 4y. What's that? That's going to be minus, that'll be 3843 equals 0. And now when I go back and have a quick check of the book, we're going to get the same thing, I'm sure. So 8.8, question 9, yeah. Okay, lovely. Okay, one last type, just to sort of finish off these sections, I suppose. What it says is find the distance from the point outside the circle to the point of tangency. Okay, so let's have a little look at this. This is from 7 to 22. Okay, so what will we take? We'll take question 19 here as our example. So we've got x squared plus y squared plus 4x minus 2y minus 4 equals 0. This is a circle. Can you tell what the center is just straight away? So you should know now that when it's written in this form, you can just take both those things divided by minus 2. So minus 2, 1 is going to be our center. Okay, what we're asked to do though is we're asked to talk about find the distance from the point outside the circle to the point of tangency. So they've given us a point, presumably it's outside of the circle, 3, 1, that's how I'm reading it at least. And it's asking us to get the point of tangency. Okay, so actually, you know, if you wanted this to be right, we know that it has a height value the same as the other one since it is 3, 1. Okay, so like you can actually say what that is going to be. And I guess in this case, it's turned into a relatively simple problem. Okay, it's turned into a relatively simple problem in that we know that this length here, you can actually just see it. We can know that that length there is 5. Okay, we know that that's what the distance is. Now you can use the distance formula to get it. There will be no problem there whatsoever. So all that you need to know to get the distance between that point and the point of tangency, what do you just need to know? Well, we know that the whole thing is 5, which we can use the distance formula to get in general. In this case, you can just look at it and say that that's what it is. But how would you get it? It is, of course, find the radius. And if you can find the radius and take it away, you're all good. When it's written like that, it's or is equal to the square root of g squared plus f squared minus c. So I kind of took a little bit of a shortcut here by dividing by minus 2. Let's be real clear. 2g is 4, 2f is minus 2. So we get that g is 2, that f is minus 1, and that minus g was minus 2. That's where I got the center from, and minus f was 1. That's also where I got the center from. So what are we trying to do? We're trying to get the radius here. So the radius is g squared. So that's 2 to be squared added to minus 1 to be squared minus the c value. C is minus 4, so minus c is plus 4. So the radius is equal to the square root of 4 plus 1 plus 4. The radius is the square root of 9. The radius is 3. The radius is 3. So I haven't drawn this to scale at all. So we know that from there to there is 5, and you can use the distance formula if you needed to. We know that the radius is 3, so this distance here between the tangent point and a point that they give, well, it's just 5 minus 3. The distance is 2. Okay, that's a good question to go on. So here's what I would suggest that you give a shot at. I would say exercise 8.8. I would be doing maybe like just some suggestions for you. Question 6, question 10, and one just like the one that I've done there, maybe question 20. That seems like a good way to go, I think. Okay, gents, what I will do for tomorrow is I will be having a chat with Dr. Clark. We're going to try and have some sort of common level of exam, not all questions, but just some. for you just for the old summer exam that we're going to have. So I'll just be really clear about what it is. I know that I've addressed it in other questions, but yeah, just to have it nice and clear what's coming up, and I'll try to give you a few hints about what to study specifically. Okay, gents, take care. All the best.